Hello and welcome to 5 Minutes of Physics. Today we're going to be looking at an experimental question from June 2009. We're going to be looking at question 2. So, after typing on his computer keyboard for several hours, a student experiences a pain in one of his fingers. He decides to calculate the pressure exerted by his finger when typing. He uses a balance to find the force exerted by his finger. He presses a key on the keyboard and then presses the top of the balance with the same force. We've got a nice diagram here of the key and the balance. So, question 1, record the reading on the balance to the nearest gram. So our reading is 86.73 grams. We need to round up 86.7 to 87 grams. State 2 reasons why the reading will not be the same as the force of the finger on the key. So you've just given me a reading in grams, and of course, force is measured in newtons. So our first and the easy answer is that force is measured in newtons, mass is measured in grams, so there's a unit error. The second thing we can think about, well, in the experimental method, it tells us that he's pushed down on the balance with exactly the same force as the keyboard. You could argue that that would be near on impossible to do, so it's very unlikely that they've hit the balance with exactly the same force, although because they've told you they have, that's probably the last answer to go to. Another thing to think about is when you're typing, you hit down the keys really, really quickly. You don't sort of create a sustained force, so it's probably not equivalent. You'd have to press down on a balance for a continuing period of time to get any readings off it, whereas a keyboard you just whack very quickly. So there's the two differences between typing on a keyboard and pressing on a set of scales. In part B, it tells us that from the internet, the students finds that a force of 0.73 newtons is needed to press a key on his keyboard. And convenient there, they've reminded you that unit of force is newtons, so you can answer the previous questions. Now, because they've told you from the internet, they've given you a value, it means that it doesn't matter anything that came before. If you did a calculation before that, they're now giving you a new value. So the diagram shows one of the square keys. It's drawn full scale. Measure the key and calculate its area in centimeters squared. Well, that means you need to get out your ruler, measure along this side, measure along that side, and then multiply the two together. It's in centimeters squared, so make sure you don't give it to them in millimeters. Next, ask you to calculate the pressure in newtons per centimeter squared exerted by the student's finger on this key and give your answer to an appropriate number of significant figures. Okay, they've been really kind to you here and given you pressure as force divided by area. They're asking you again for pressure in newtons per centimeter squared rather than pascals, so that makes it even easier. You've been given the force in newtons and you've just calculated the centimeter squared, so you're going to divide them by each other to give yourself the answer. The key thing here is an appropriate number of significant figures. Now, significant figures you should always only give as many as the least accurate piece of data you have. So, if we look back at what we're looking at, we've got 0.73 newtons as our force, and you've got probably to the nearest 0.1 of a centimeter in your reading of the length. So if your centimeters, the length is sort of 1.6 centimeters, you've got two significant figures there in 1.6. You've got 1 and 2 significant figures in the 0.73 newtons. So your answer for the pressure should only be to 2 significant figures, because that's how accurate your data is. When you do your division, you'll probably get a huge number on your calculator, but only give it to 2 significant figures. And for our final question, it asks us to just justify why our number of significant figures is appropriate. It's appropriate because you have to give the same number of significant figures as the data is accurate to. Our data is accurate to 2 significant figures. It was 0.73. So remember, that's 2 significant figures. It doesn't matter how many decimal places you have there. The 0 does not count as a significant figure in 0.73. So you have to give your answer to as many significant figures as is appropriate. Now, you normally won't be marked down for giving it to 3 significant figures, which is a standby I know from your maths GCSE, unless it tells you specifically to give it to an appropriate number of significant figures. In that case, you're going to have to make a judgment call and only use the smallest number of significant figures in any of the data that they've given you to do the calculation. Good luck with your revision.